Welcome to Chapter 4. Chapter 4 is going to be kind of the opposite of math. We're going to be doing a lot of not numbers related things. We're going to be talking about how we collect data. So dealing with samples, dealing with experiments, and dealing with the things that go wrong with those things. So we're going to start with section 4.1a today, just talking a lot of sampling vocabulary. So can you identify a sampling method that's being used? That's kind of our main goal today. So ultimately, there are four primary methods of obtaining data: published sources, observational studies, we'll get more into that, controlled experiments, and surveys. We're going to start talking about surveys today. All right, first of all, um, what is a population of interest? So population of interest is the entire group of individuals that we want info about. Okay, so if I was going to do a survey at our school, our population might be the entire school body, only a school student body. That might be my example, and I want to know some things about the school. So I'm going to narrow it down to my sampling frame. A sampling frame is basically what group I'm picking to sample. So I'm picking, let's just say I'm picking the junior class. Okay, from the junior class, I give out this survey to everybody, and I get a certain number of responses. So let's just say junior class, 350 students. I get the sample from my data, and only 200 of those people responded. That is called my actual sample. The actual sample is the 200, oh, I said 200, 200 responses. So it's a subgroup from the sampling frame we have responses from. Okay, sometimes we'll get the whole group, sometimes we won't. So the actual sample is the actual ones we have. Now, a couple other things we're going to be talking about. Census. A census, you might have heard the term census with, in our country, we do this every 10 years. There's a census of the entire country. It is a collection of data from every individual in the population. So from that population group, from that census, we can find the mu, which is our population mean. We can find the sigma, which is our standard deviation. We can find proportions. But it is from everyone. We want to get everyone's data. Okay, not a certain sample. It is from everyone. And then the last thing I want you to know right now is, what is a variable interest? A variable of interest is really just whatever we're looking to get information about. So we're sampling about, it's a topic or what we're interested in finding more about. So I've got a couple examples for you. And with these examples, I'd like you to think about the population, the variable of interest, the sampling frame, and the sample. So here's my first situation. Fred wants to know what percentage of Southwest patrons, that's, airplanes, Southwest airplane, is happy with the service. So he goes to the Southwest terminal in Milwaukee, asks the first 100 customers who get off a flight, and asks them their opinion. He gets 90 responses. So my population of interest for this, based on the situation, he wants to know based on the opinions on Southwest from all Southwest patrons. Like, that's his population. He's looking at all the Southwest people, all the people who fly Southwest. That would be his population. Okay? What he's looking for is just whether they are happy with the service. That would be the variable of interest. So however he frames his questions, he's going to get responses on that. Now the sampling frame would be the first 100 who get off. But the actual sample is only the 90 who responded. Okay? So that's the difference between these different things, these different terms we just talked about. I'd like you to look at this second example, and you can pause it and answer those questions on your own. Again, what is the population, the sampling frame, and the sample, and then the variable of interest. It says Abigail wants to know that what percentage of Hamilton High School seniors are planning on going to a four-year college. She writes the name of each senior on a note card, places the cards in a hat, and without looking, randomly selects 50. After emailing 50 seniors, 14 replied. So what are each of those 4 things in this problem? Pause it and try it. All right, hopefully you tried it. The population is the Hamilton High School seniors, because that's who we're trying to look for here. Not the whole school, just seniors. The variable interest is who's going to a 4-year college, basically whether you're going to a 4-year college or not. Specifically, she's looking for a percentage. The sampling frame would be the 50 seniors that were randomly chosen. And then the sample, unfortunately, is pretty small. It's only the 14 people who replied. So that's the first terminology I want to talk about. Now, along with some of that terminology comes some things that we've already learned, and the parameter versus the statistic. So let's do a little recap here. Parameter deals with a population data. Statistics deals with the sample data. So that's the first letter kind of gives it away. Parameters are population data. Statistics are sample data. And specifically, the parameters that we're going to be looking at are these 3. Mu, which is our population mean. Sigma, which is our population standard deviation. We've worked with both of those in the past. And then P, which is our population proportion, is another statistic we're going to be finding. Like, what is the proportion of blank? Statistics, same sort of deal. It's just X bar for the sample mean, S sub X for the sample standard deviation, and P hat is our sample proportion. All right? Now, keep those in mind, because when we're dealing with sampling, we are going to be getting statistics generally from a population. So the statistics will be coming from a sample which will hopefully be able to represent a greater population, depending on how we do things. Unless it's a census, and a census would be of everyone. Now, when we're doing these samplings, there are different types of methods that are done. So there's some that are legit and good, and some that are not good or illegitimate. So here's a list of all the ones that we're going to briefly talk about in a moment. One of them is an SRS, that is just a shorter term for a simple random sample. That's the first one I'll talk about in just a second. Simple random sample. We have something called a stratified random sample, a cluster sample, systematic sample. Then we have a couple other ones that are less commonly used, multi-stage sample or quota sample. We also have some illegitimate ones, convenience samples, self-selected samples, and I'll even add one on there that we're going to get to, sometimes called a judgment sample. Probably way less common, but it is a thing. Kind of a convenience sample, but it's based on a little bit different. So let's talk about each one individually. What is a simple random sample? For these, I'm going to use an example of a concert. So let's say you go to a Taylor Swift concert. So we've got Taylor Swift up here on stage. We've got all these different sections facing them. There's different rows within each section. So if we want to learn about these fans and their experience, one option for surveying them is a simple random sample. So a simple random sample is kind of the golden sampling method. It's the most commonly used. When you see samples, usually this is what's done. So where every element of the population, so all the people at this concert, is equally likely to be selected, doesn't matter where they're sitting. Every element in this is selected independently, so if the person next to me is selected, I can still be selected. It's not impacted by who's selected. And every subgroup is equally likely. So you could say every individual section has an equally likely chance, every row has an equally likely chance. You're just putting everybody's names into a hat, and you are going to you're going to sample 50 of them. And we'll talk about different ways to do a simple random sample in the coming days. Another type of sample is a stratified random sample. Okay? So a stratified random sample is where you divide the population into groups called strata of individuals that are similar in some way that would be important to the response. So if I'm trying to survey people about how they feel about Taylor Swift concerts, I don't know if it's this, like, I would say people in the front row are going to have a definitely a different um, a different opinion, like I'm just going to say front row all in general, than people in the back row. So my stratas might be my rows. Because if you have a front row seat, you're going to have a way different experience than a back row seat most of the time. So you're going to choose a separate simple random sample in each strata or stratum. So you're going to take row 1, pick a random sample of 10 people. Row 2, pick a random sample of 10 people. Row 3, and all the way down to the back, you're going to pick a random sample from each row. So we have a sample from each level closest to the stage, and then we're going to sample that. We're going to combine those to make our sample. Another type of grouping is called cluster samples. So this is different because a cluster sample is where you divide the population into groups called clusters, usually by proximity, but every member can only be in one group. And these groups don't necessarily have something in common. Usually it's just proximity. But then you're going to pick random groups. So randomly choose some of these clusters and have a reason why you're clustering them the way that they are. But all individuals in the chosen clusters are included in the sample. So I might have my Taylor Swift concert, and I could take, there's my Taylor Swift concert. I might just say my clusters are the 6 sections. Okay, there's nothing necessarily in common between them because there's front row, back row in every section. But each of these 6 sections, I might randomly sample 2 of them, and you get everybody from that cluster. Okay, that's a cluster sample. So a visual comparison is here between strata and clusters. Strata would be similar within each group, but different between them. And then within each group, you're just taking a random sample. Whereas clusters have different within each group, but you're like if you have 6 clusters, you're sampling the entire 2 of them, okay, or 3 of them, whatever it is with your specific sampling. So that's the difference between strata and clusters. Another one that's again less common would be a systematic sampling. So this is where you order every member of the population in some way, shape, or form, be able to explain why, and you select a random starting point. So let's just say we put everybody at the Taylor Swift concert in order from age, or in order from ticket number. It's got to be some order, and then I'm just going to say I'm going to pick every 12th person, and that's how I'm going to survey them. Okay, it is a legitimate way to do it. It's not super common. It's not super easy necessarily. But the starting point and end do not have to match up. So like you might have like the 9th person be your starting point. You don't have to have 9 people total. It's just going to be every nth person after that. So 2 different types that we are very uncommon, but can happen too, is a multi-stage sample where you're going to do layering of samples. This is really where you're doing multiple methods in one. So that's kind of called multi-stage. So you might, I mean, clustering is kind of that way, or strata is kind of that way. You're doing, or clustering, you're doing a random sample, grouping them, and then doing a random sample of each group. But multi-stage is a term for when you're doing multiple methods. And a quota sample is using proportional representation of each group. So if you know anything about how like the House of Representatives works, House of Representatives is proportional to the size of the state. So state population. So in Wisconsin, we have, like every state has 2 senators, but House of Representatives, what do we have, like 8? And that is just based on size, where California has like 50 some. So it's just proportional to the state size. That is called a quota sample. So those are all the possible sampling methods that are legitimate. Now let's talk about something else. Bias is a big word that we're going to use in this unit, because in survey sampling, bias refers to the tendency of a sample statistic to systematically over or underestimate a population parameter. So it's something that's causing the numbers to be wrong. Okay? It does not have to do with personal opinion like we think of with bias. It has nothing to do with that. This has to do with what is causing our data to be wrong. So many things can cause a bias in a study. One of them is poor sampling methodology. It's the most common one. So poor sampling methodology, let's talk about a couple of different illegitimate methods. So first one, convenience sampling. Convenience sampling is just surveying people who are readily available. Like, ooh, first 10 people in the school, I'm going to survey the first 10 people here. But is that good? No. Is it easy? Absolutely. It might be like, if we're talking about what time, like the question is, what time should school start? And we sample the first 10 people in the school. Well, they might want it to be earlier and not be a good representation of the whole school. So that's convenience sampling. Another one that's a commonly used one is self-selected or voluntary sampling. So it consists of people who choose to respond. So choose themselves by responding to a general invite. Theoretically, all members of the population do have a chance to respond, but they're chosen. And this is normally not good. There's usually some sort of bias in opinions. So I'm just going to make a note that a lot of times self-selected are like internet surveys or radio surveys. You hear those people call in on the radio, and it's self-selected. It's the ones who have the biggest opinion. They're the ones who call in, and everyone hears it. But other people just don't call in. So you get very opinionated responses. And the last one I want to talk about is judgment sample. It's kind of uncommon, but this is where an expert who theoretically knows about the sample is the one selecting the sample. Okay? So if we wanted to pick from the school and have a tug of war competition against the teachers, and we say, all right, Mr. Let's just, I won't use names, but let's say our football coach is the one who gets to choose. Well, he probably knows who some of the stronger people in the school are, so he is an expert in the sample, and he's going to pick those people. It's not really random. So that's what a judgment sample is. All right. Now that we've talked about all those, quick recap. Back to this slide. We have a simple random sample, which is just a sample from everybody. Take the whole group, pick random out of a hat. Stratified is where you have groups of similar things, like each row at the concert, they're similar. They all see it at a certain level. And then you do a random sample within them. Cluster sampling, that's where you take groups that aren't necessarily similar. Maybe if you're looking for the city of Sussex and you're going to go by neighborhoods, and then you randomly sample the entire neighborhood, like 5 entire neighborhoods. Systematic is where you pick like the 9th person, and you go every 9 people after that in some order. Multi-stage and quota, those are more or less common. We've got convenience samples where it's just what's easy. Voluntary sampling or self-selected, that's where it's you choose to respond. And judgment is where someone has some prior knowledge about the group. So I'm going to give you some examples, and I want you to decide which ones they are. That's how we're going to wrap it up today. So let's do number 1. Abigail wants to know what percentage of Hamilton High School students are going to four-year college. So that's right there. She writes the names on the senior of each senior on a note card, places them in a hat, and without looking, randomly selects 50 of them. What is this? It is a simple random sample. She's taking everybody and picking random 50 out of it. Number 2, Ben wants to know what percentage of Hamilton High School students are planning on voting in the upcoming election. He randomly generates a number from 1 to 4 on his calculator, places a survey in that teacher's mailbox, and surveys every other teacher in a like manner. So it's like every 4th teacher. Well, that's systematic. It's every 4th. So every fourth teacher is going to get them, get the question. Carly wants to know what proportion of Sussex residents can name their 2 United States senators. She stands outside Culver's and asks the first 50 people she meets and asks her the question. Well, this is a very convenient way to do it. It's called convenient sampling. So not a good one. Number 4. David wants to know what proportion of Wisconsin residents think that Brett Favre is the most successful Green Bay Packer in franchise history. He obtains a list of all Wisconsin citizens from the Department of Revenue, randomly generates 100 numbers that correspond to each person in the population, and contacts them. That is a simple random sample. He's taking everybody. Everyone gets an equal chance and picking random 100 people. All right, number 5. Emma wants to know what proportion of teenagers care about Justin Bieber's latest romance. Actually, I think he's married now. But anyway, Emma places a survey in 17, it's a magazine, and asks interested individuals to complete the short questionnaire. That is voluntary. That is self-selected or voluntary sampling. Because only people who really want to give their opinion are going to give their opinion. All right, number 6, Fred wants to know what percentage of Southwest patrons is happy with the service. He goes on the Southwest terminal, asks the first 100 customers. So we talked about this example. That one was also a convenience sample. All right, I've got 3 last ones. Number 8, Hope wants to know what Americans think of gasoline prices. She randomly calls a proportional number of citizens in each of the 50 states. So each of the 50 states, she does a certain proportion. That is a type of stratified sampling because it's groups and then sampling within. But if it's proportional, it's specifically a quota sample. So it is a type of stratified random sample. Isaiah wants to know what Templeton Middle School students think of Hamilton High School. He randomly selects 2 7th grade houses and 2 8th grade houses and asks everyone in that house to complete a survey. That would be taking a group of a variety of people, randomly picking a few groups and sampling everyone in that. That's a cluster sample. And lastly, I don't know how we got to 10. We must have skipped a number somewhere. Maybe we skipped 7. But Jacqueline wants to know what proportion of boxes of Cheerios contain less than designated 18 ounces. She selects every 100th box, then comes off the assembly line and weighs them. That's the systematic one. It's every 100th box. So those are, whether they're good or not, those are all different ways of sampling. And that's what we want to get to today, understanding the basics of these sampling methods. And we're going to go into more detail in the coming lessons. That is section 4.1a on sampling vocabulary. We will see you next time.